Hello, my name is Ryan Thompson, and these are my colleagues Ernesto Manzano, Patrick Clant, and Noah James. And together with TI, we worked on IoT sensor system design and optimization. An IoT sensor system is any system that is a low form factor, low power system that continually transmits data. For our purposes, we were looking at two different factors in order to optimize our system. The first is battery lifetime, and the second is capacitor leakage. Capacitor leakage is not something that's been formally characterized before now because in general use cases, it's so low that it doesn't necessarily matter. But as the systems become lower and lower power, it's something that we're starting to look into as a potential issue. Our project was broken up into two phases. In the first phase, we designed and then constructed our systems in order to actually measure these two different factors. In the second phase, we reiterated on these designs, making them more accurate and more user-friendly, as well as concurrently designed our own IoT sensor system to use as a kind of proof of concept of these systems. So the first system was in order to measure the battery lifetime. We needed it to be able to test different conditions, so for example, different load patterns like a constant load, constant current, or a pulsed load, most commonly what we'd see in IoT sensor systems. Up here you can see all the way on the right we have an example of one of our tests that we ran. This is 4 different manufacturers of battery run under the same conditions in order to tell which one would be able to last the longest. We can then use this data to make a recommendation as to what the system would use under these particular circumstances. Our second system is able to measure capacitor leakage. It is able to simultaneously run 4 different systems, or rather, sequentially run 4 different capacitors before you need to give it another input. Our example here is the same manufacturer under the same conditions, but with different capacitance values. And so we would combine these two pieces of data together to kind of make an overall recommendation on our system. The system that we designed is a temperature and humidity sensor. So it continually records sensor and temperature data, and then it will transmit it periodically to a host board where we can then log it and keep that data, log the data over time. So we could take this as these are the conditions we need, and then use those conditions in order to kind of format our testing on the other 2 devices. Use those tests to kind of say, okay, these are the capacitor values we recommend, or these are the batteries we recommend. Overall, we were able to kind of profile these batteries and capacitors under these particular conditions in order to make recommendations for our system. But you could also in the future take any kind of arbitrary IoT system and then take the circumstances from that system, apply it to our test structures, and then kind of use that in order to further optimize your system. Any questions?
Yeah, what percentage is your, before you started this research, what percentage of the power usage was due to typically the capacitors, and then with your proposed capacitors, what percentage, how much did you improve that percentage of power usage from the leakage of the capacitor?
Generally, IoT systems run in microamps of current nowadays, but TI is looking into applications that run into nanoamps of current, and these capacitors leak roughly hundreds of picoamps. So by optimizing the specific capacitor, you could see a performance increase of like 10%.
Okay. What sort of capacitors were you using?
We're using multi-layered ceramic capacitors.
And what microfarads?
My lips are sealed. I'm bound by NDA, so I can't reveal that information.
Well, we can tell more kind, I think. Just like we were using lower microfarad capacitors.
1 microfarad, 4.7.
Yeah, just general microfarad.
Yeah.
Not tantalums, though. That's the main thing. They have really high leakage.
Next question. At what temperature do you run your tests?
So they asked us to run temperature tests up to the voltage or up to the temperature rating of these capacitors. So we ran a test at 40, 60, and 80 degrees Celsius.
Thank you very much.